Hey y'all, welcome to lesson 3.3, where we are going to talk about valence electrons. Um, I put this way because that's the place in your notes I want you to start. So find that little curved line that says valence electrons, and we're going to fill in the space right there to start out. Um, so first, a definition. Valence electrons are the electrons in the outermost energy level of an atom. So remember when you did those Bohr models and you did 2 electrons in the first energy level and then 8 in the next one and then ever how many in the next one until you had all the electrons filled in? That outermost ring, those are called valence electrons. So they are the ones that really, when we talk about chemical bonding, they are the ones that are most important. So obviously they're the ones held most loosely by the atom because they're furthest away from that positive nucleus, right? So the negative electrons, positive protons attract each other. Um, but because they're further away, they are held more loosely. And that's in chemical bonding, gaining and losing electrons is a huge part of that. The number of those valence electrons determines the atom's properties. So they determine how the atom behaves, basically. And remember, we talked about in the last video, things in the same group, in the same column, have the same type of properties. Well, atoms in the same group have the same number of valence electrons most of the time. So everything in group 1 has the same number of valence electrons. Everything in group 2 has the same number of valence electrons. So that makes it real easy to figure that out without actually having to draw a picture or anything like that. So when we talk about atoms, I know I've said this before when we talked about photons and light and energy when we were making our sparklers, but atoms want full energy levels. It makes them stable. Like I said, everything in nature just wants to be stable. One thing that makes atoms stable is to have full energy levels. So if they have an outer energy level with just one electron, they're going to want to donate, get rid of that electron, share it with somebody, somehow get rid of it so that they have full energy levels. If their outer energy level has maybe 7 electrons, remember we said 8 is full, then they're going to want to find an electron from somewhere and fill up that outer shell so they have 8 electrons. And then what happens there is a bond occurs between the one atom that is giving away an electron and the other atom that is taking it. So then they sort of share a special bond. But what atoms want is that full energy level, makes them stable. Sorry, I just went through a million different things all at once there. All right, moving up to the top of your notes. You can see here are some examples of some atoms: lithium, beryllium, and boron. Lithium has 1 valence electron. You can see there in this first energy level it has its 2 electrons, and then there's 1 in that outer energy level to make 3 total electrons. Beryllium has 2 valence electrons, again 2 in that level and then 2 in the outer level for a total of 4. And boron has 5 total, 2 and then 3. So atoms like this, with fewer valence electrons, like I said, are more likely to lose them during a chemical reaction. They form a positive ion. Remember we said that was a cation with full energy levels. So lithium is going to want to lose this electron, form a chemical bond, and then only have 2 electrons in the full first energy level. Okay? So we might be thinking right now, well, what happens to those electrons, right? Well, that is where these atoms kind of come in. Like fluorine here, it has 7 valence electrons. So it is easier for it to gain 1 more than it is to lose all 7 of these. If it gains 1 more right here, then it has 8 in its second energy level and it's full and it's happy. So lithium has its 1 to give away, right? Fluorine needs 1, So they basically form a partnership. They form a chemical bond, they work together. Lithium gives its electron to fluorine, and then fluorine has a negative charge, like it says here, gain electrons to form a negative ion. Lithium has a positive charge, like we said before, and then they will be attracted to each other and form a chemical bond. So those are basically valence electrons. They're the outermost energy level. I think we're flipping over to the back of your notes now, or to the second page. So the page with the periodic table. Sorry, I had to look at mine really quick. But atoms in the same group react in similar ways because they have the same number of valence electrons. I said that before. We said it in the last video. Same group, same column, same properties because they have the same number of valence electrons. So example, everything in group 16, they all have 6 valence electrons. Everything in group 17, they all have 7 valence electrons. If you look at the periodic table in the back of the classroom next time you're in there, you will see at the top they're actually labeled 1, 2, and then skipping that D block there because we don't do a whole lot with that, and going over to boron 3, 4, 5, 6, 7, 8. So they're actually labeled with the number of valence electrons that they have. So what I want you to do right now, like it says in your notes, color this periodic table. Color each group a different color. I guarantee I'm going to be looking for that in a couple of days. So do that. See, here's a pretty picture of it. Looks like a rainbow. Color it however you want. Just make each group the same color. All right, so what about those other elements in those other blocks? I'm looking for a periodic table. So we are going to be dealing mostly with these elements in the P block, these elements in the S block, these first two groups. All of this in the middle, we don't do a whole lot with. Those are the D, that's the D block right there, and then this group that's separate here at the bottom is the F block. They are a little bit different because the valence electron number is not always the same, and it's not easy to predict. Like it says here, some of them lose 2 electrons, some of them need to gain electrons. It gets a little bit murky about valence electrons in that column, or in those blocks, sorry. So we don't do a whole lot of talking about those. Again, we are concerning ourselves really with groups 1, 2, 13, 14, 15, 16, 17, and 18. Those transition metals in the middle, we are going to kind of leave alone for the most part as we move forward here. All right. So here's a better picture of that. These blue ones, the S block, these green ones, the P block, that's where we care about. The pink and the yellow here, the D block and the F block, a little more vague. We will talk about them briefly, but we will not spend a whole lot of time talking about these elements.